All right, good morning there, Math 20-1. Here we go. We are into factoring applications lesson 3. We're going to factor trinomials in the form a to the squared b x and c. They're basically going to be different looking things, but we're going to have different degrees. These degrees, generally we see at degree 2, 1, and 0, which is this here, this x squared plus bx plus c. But we're going to get into is degree of 4, 2, 0, or 6, 3, 0, or it could be 8, 4, 0, and so on. All right, and so what we're going to do is make substitutions, all right, which allows us to use this. All right, so for example, you guys can read through this example here, it should help you out. What I've already done is to make these videos a little bit shorter is I've filled out the first one for you. All right, go ahead and take a look at that and notice what I've done. All right, in this second one here, we have a degree 4, right? Degree 4, then degree 2, then degree 0, right? Then the third one we have a degree 6, a degree 3, then a degree 0, right? When it's like that, it doesn't look quite the exact same. We're used to seeing it in degree 2, degree 1, a degree 0. But as long as we have a degree, then half, and then 0, we can still do the same problem. In this case, what we're going to do is we're going to use capital A and say that capital A is equal to x squared. What this allows us to do is say that the first one here is a squared because x squared squared is x to the 4, right? So what that allows us to do is say that that is plus 4x, oh sorry, not x, we should a like I was just doing it, plus 4a minus 5. Now this looks like what we originally have and how we've learned about decomposition and inspection. So by inspection, right, my numbers are going to be -1 and 5. So this gives me a -1, this is inspection, and a plus 5. When we get to the end, we're going to resubstitute in our original values, right? So originally we said a equals x squared, so our final answer is x squared minus 1 and x squared plus 5. Okay, we can do that for anything, even with cubed, right? We can say here that a equals x cubed. Since a equals x cubed, we can then say this is a squared minus 9a plus 14. All right, with that we can do inspection. Our numbers are -2 and -7, so it becomes a minus 2 and a minus 7. Put in our original value for what we substitute a in, right? This is called substitution method. And we come with this. Okay, so that's what the first one looks like. That's the substitution method. Once you get good at this method, you won't even need to do the substitution, and we'll see that kind of in the next page here. All right, so our method 1 is using the substitution, and method 2 is just by looking at it and noticing the patterns and doing the same. What we're going to look at without doing the substitution is just the whole numbers, right? As long as it follows that pattern of 4, 2, 0 or 6, 3, 0 for degree, or anything like that, as long as it follows that pattern, then we can just solve it the same, just looking at the whole numbers. As you can see here, I've done this first question without substituting, right? It followed the degree 4 to 0, so I used my decomposition and broke this down, right, as we go. So I broke this down, I did my grouping, right, I used decomp, did my grouping, and it worked out just fine. Again, you don't have to do the substitution. All right, again, let's look at this one here. Right, we gotta make sure it follows the pattern, the proper degree pattern. Well, the first term here is degree 4, right? 2 and 2 is 4. The second term is degree 2, and the third term is degree 0. So what we're going to do is we're going to break this down the exact same way we normally would, except for we're going to use our decomposition, right? So decomposition, we have to do 2 times 99, which is 198. So that's multiplied to equal 198. And it has to add to be 31. Sorry, -31. Okay. I happen to have the answers in front of me. This is where you're going to guess and check until you can figure it out. The answer is this is negative 22 and negative 9. So we're going to use those, all right? So we'll break it up just like we normally would, okay? So keep the front one the same. B squared. Do our minus 22 AB plus negative 9 AB. Make that one neater for you guys. AB plus 99. Now what we're going to do is we're going to do our grouping, right? Set up our groupings, put that negative inside like we did with decomposition in the last lesson, and factor out what we can, right? This one here, right, we can factor out a 2 and an A and a B, right? So we're going to take 2AB out, which leaves me with AB minus 11. This one here, we're going to take out negative 9, which again, these are positive AB minus 11. We took that negative out. That's important. We're lucky again. These work out, right? That's why we do the T-chart, which is the proper decomposition. So we end up with AB minus 11 and 2AB minus 9. Okay, so just keep that in mind as we go. All right. This is what that looks like. So that's that question. If you want to copy down the other question, it's right here. Okay, don't forget you can pause the video at any time. Just do that. All right, we're going to factor this expression completely. All right, so we're going to start with our T-chart over here. All right, it has to multiply to 24. Okay, whenever you see a question that says factor completely, watch that. That probably means we're going to be able to do more than one step, okay? Generally, we're always going to look for more than one step, but when you see factor completely, it means more than one step in general. Okay, so I've got 24, and it has to add to positive 10. My two numbers I'm going to use then are going to be positive 12 and negative 2, right? Has multiplied negative 24, sorry. So positive 12 and negative 2. So I'm going to keep my things the same. Front is the same. Do my minus 2x squared plus 12x squared minus 3. Now I've got my groups. Set them up. Check the front one. What can we take out? Well, we can take out a 2x. So take 2x squared, sorry. Which leaves me with 4x squared minus 1. The second one, we take a 3 out, which leaves me with 4x squared minus 1. Our factors end up being the same, 4x squared minus 1 and 2x squared plus 3. Okay, so that's where that question kind of ends up. Now we have to double check. It said factor completely. We look over here. If I want you guys to do is take a second and look at these and pause the video right now and see which of these two can still be factored and why. Okay, so if you looked at the left one here and you saw it was difference of squares, you'd be correct. That is difference of squares. So you get 2x minus 1, 2x plus 1, and then 2x squared plus 3. Okay, this goes like that, right? That's a difference of squares. So this is our final answer. All right, our final answer looks like that. There's the whole question for you if you need to pause the video and write that down. All right, there's that whole page. Okay, again, this last page, I've already done the first question for you. I can zoom in so you can kind of take a look at what I did. It's not the neatest in the world, but it's not bad. All right, this one, just because instead of writing sign every time, I wrote the replacements. It just takes a little bit longer to write that. I like using A as a replacement, okay? Keep in mind that we have this up here. That sine x is written like this, right? Cos x squared is written like this, okay? Remember the squared kind of goes on the inside. We saw that in our trig unit a little bit. All right, this one here, just because I'm using the stylus and I can't write very good, I could do this without using the replacement, but I'm going to use the replacement. Remember, even with or without replacements, our still main focus is on the whole numbers. All right, so I'm going to go ahead and I'm going to say that I'm going to use A as a replacement for cos x. All right, I'm going to use A as cos x. All right, so that allows me to do 4a squared plus 11a minus 3. All right, then I can go ahead in my decomposition. Right, I've got 4 times 3, so negative 12, and positive 11 is what it needs to add to. Multiply to positive negative 12. Okay, do your guess and check, find those numbers. Right, these numbers are going to be negative 1 and positive 12. All right, so I've got 4a squared minus 1a, okay, plus 12a minus 3. Do our groupings, right? I'm just using this blue pen just so you guys can see a little better that I'm adding these groupings in without it kind of being distracting. The front one I can take an a out of, which leaves me with 4a minus 1. And the back one I can take a 3 out of, which means 4a minus 1. Finish grouping. Sorry, finish decomposition. Let's look like that. Once we get to the end, we always substitute back in our original values. Do not leave your answer like this because that's wrong. Okay. All right, so it looks like that. Remember, you can use a substitution for anything as long as it follows the degree that we set out, right? This degree is degree 2, degree 1, degree 0. This one here is degree 2, degree 1, and degree 0, right? Okay, and that question works the same as here, right? So this question here, we're supposed to factor this. And what I notice is I've got this here, this x minus 3, but I notice that the x minus 3 is to degree 2. Then I've got x minus 3 to degree 1, and then I've got no degree at all. This still follows the same pattern. So I'm going to replace that entire thing with a, right? Put that in. And so what I've done is I replaced that equation, and it looks like this, right? So 7a squared. And then I always write this down. You have to write this down so that at the end, you know what a meant. Once I get to the end, I factor it. So this is just decomposition, right? A regular decomposition. Once I get there, I put my letter back in, right? Or I put what my original value for a was back in, and then I have to simplify, right? I have to simplify from here to here. That simplifying is a big important step, right? If you do that wrong, okay, you can't leave your answer like this. It has to look like that, right? Your final answer has got to be in the original form with the letters you originally started with, all right? So we can go to this one here. I notice that pattern again, right? You notice that pattern, degree 2, degree 1, right? Degree 2, degree 1, degree 0. That pattern is like that. So what I'm going to do is I'm going to replace the entire thing with the letter A. So I'm going to say that capital A represents A plus 4. All right, this gives me 9A plus, plus A minus 10. All right, notice there's no coefficient in the second term, so it's just 1A. All right, so my numbers, my little t-chart here, it has to multiply to negative 90 and add to 1. So my numbers are negative 9 and 10. Negative 9 and 10. So we're going to go ahead and do that. This is 9a squared minus 9a plus 10a minus 10. A little better. There we go. All right. Now I can do my grouping just like we've done with all the other decompositions and to factor out we can. So the front one, I can take out a 9a, which leaves me with a minus 1. And the back one here, I can take out a 10, which leaves me with a minus 1. Alrighty, so I factor that away. A minus 1 and 9a plus 10. Alright, so we've done the decomposition, but now we need to substitute back in what we originally used, right? This a represented a plus 4. So we're going to do a plus 4 minus 1 and 9a plus 4 plus 10. right? Now that's going to work just fine. Now we got to substitute this. This is a plus 4 minus 1, so this is a plus 3. And this one becomes 9a plus 4 times 9 is 36 plus 10. Right, I just distributed that in. Okay, so our final answer is a plus 3 and 9a plus 46. That's our final answer there. All right, so that's the end of this lesson, you guys, for today. Good luck. Let me know if you have any questions. Remember that you guys have a Google meeting time with me where we can go through questions and stuff like that. It's been emailed out to your parents. Make sure you check that stuff. All right.